Well, good morning or good afternoon, good evening, as the case may be. My name is Vic Thomas, and I'm a principal software engineer at Medallia, working in the performance and observability engineering team. For the next 30 minutes, my colleagues Anugrah, David, and I will give you a highly summarized account of the mandates and challenges and successes that we've had along the path of Medallia's journey toward unified observability. In this session, we'll give you an overview of challenges, how we overcame them, and where we're heading next. We suspect that much of what we discuss will resonate with many or most of you. So today, the visualization of Medallia's observability is centered within Grafana as a single pane of glass. But the path to getting here has been a bumpy one. So maybe hearing our story will give you confidence that you can achieve your observability goals. So who is Medallia, you might be asking? Medallia is the pioneer and market leader in experience management. We capture feedback signals to provide understanding and management of customer and employee experiences. These feedback signals come in a variety of forms. They could be in-person human interactions, so maybe a store transaction or a hotel stay, followed up by a survey. Signals could be coming from virtual interactions like a website or a call center interaction, or video or social media interactions. There's just a lot of different ways that these feedback signals come into our system. Customer experience is a primary focus, but so is employee experience, because to make your customers happy, it's important for your employees to be happy. So one thing that we find sort of appealing or interesting is that there's a bit of a transitive nature to observability at Medallia, because much like how Medallia captures and processes experience feedback signals so our customers can optimize experience for their customers and employees, observability within Medallia is capturing and processing observability signals so we can optimize the experience of our customers using our software. So I'd like to make an assertion here. And that assertion is that in many or most contexts, heterogeneity is an advantage. So for example, in 2016, the Harvard Business Review published an article citing a McKinsey study that demonstrated the business benefits of workforce diversity within teams. So this takes many forms, like skills and experience, of course, but also ethnic, cultural, gender, age, and a variety of other forms of diversity. And so you may have also noted from your own experiences that diverse teams help to minimize skill gaps. They minimize blind spots. They help to then therefore make better decisions, foster creative solutions, and ultimately, what really matters from a business perspective is to increase productivity. In another realm, financial planning and investment. Many years ago, the economist Harry Markowitz came up with a mathematical model that's now thought of or referred to as modern portfolio theory. And in this context, diversification is very important to help maximize returns subject to a particular risk tolerance while minimizing idiosyncratic asset risks. So again, diversification, a good thing. And just real quickly, another example, health and wellness. Having a varied diet is essential for good health. And for most of us, it's a better culinary experience to eat a variety of foods. For those of you with young children, maybe this doesn't apply, but for the rest of us, I think you'll see the truth in it. So this is great. Diversity, heterogeneity, good things usually. But in software as a service operations, heterogeneity can actually be a significant challenge. So I'm going to make another assertion here. And that is that the growth of a company necessarily increases heterogeneity. For example, as the company grows, teams begin to specialize, new teams are created, and knowledge gaps form as those teams specialize. New features are developed as the company grows, and this is critical to improving competitive positioning. But those new features introduce opportunity for deviation from standards or knowledge that was previously had by other people on the teams. And as time goes on, the deployment and operation of software evolves. What may have started off as a very manual process, but only handled by a small number of people, maybe becomes more automated, and more people get involved. Innovations occur, and sometimes there can be complexities in that journey as well. And there's many other ways that heterogeneity can be a challenge in SaaS operations. Entropy is definitely for real. So at Medallia, we definitely faced this challenge of increasing heterogeneity due to growth. And the path toward our current level of operational complexity is really a story that's evolved over 20 years' time. This graph is an approximation of the growth of our customers and employees. And it looks very similar to this graph, which is showing the approximate growth of our product offerings and vertical markets that we serve. And you'll notice that the inflection point occurs at about the same point in time for both charts, which is maybe around 10 years ago or so. And so if we go back over the last, or over a time period of 5 to 10 years ago, we reached a point where it was pretty clear that being able to observe what is going on in our applications and services and hardware was critical for us to be able to continue to grow and to scale. Unfortunately, what we've had occur is various teams throughout engineering started building solutions that were disparate. They were separate solutions for specific pillars of observability. And as their solutions moved forward, they diverged, their utility was limited, and progress was stalled. And from an end user's perspective within Medallia, it was a mess because, okay, a few years ago, we had metrics in Grafana, but logging was in a different user interface, if at all. Some analysis, people just had to go straight to the source of logs. Tracing was in yet another user interface. Not ideal. It was a poor experience for Medallia employees who are users of observability. So January 2020, just a couple of years ago, it was obvious that we needed to have the various flavors of observability underneath the ownership of one team having a unifying vision. So the performance and observability engineering team, or the POE team, was created, as I said, in January 2020, to bring those flavors under one team with one vision, but also to help reduce mean time to detect, and also to leverage the power user knowledge of the precursor team. So before the POE team, we had the performance engineering team, on which both David and I were members. And we knew a lot of what we could do and what we couldn't do. And I think as a result of complaining, the ownership got transferred into our team. But that was actually a great thing and a great opportunity and experience for us to take it forward to the next level. So I don't want to talk too long about this particular slide, but complexity can just explode when you have the cardinality of various dimensions related to operations. As those grow, it becomes sort of a Cartesian product kind of explosion. So, and this is definitely where we've been in the last few years. Soon after the team was formed, Medallia had a rapid increase in acquisitions to complete our offerings, our product offerings in the suite of products that Medallia can offer related to customer and employee experience. So that created a lot of challenges because we now were operating in different regions internationally with different regulations. We had more programming languages to deal with, various data center types, infrastructure, types of applications, you name it. So the challenge became, even greater than it already was. The cardinality of each dimension increased, and the combinatorics of it all was daunting. So now that I've given you a brief introduction to our history and our challenges, I will turn this presentation over to Anugrah, who's going to talk about metrics, where we've been, where we are, and where we want to be.
Thanks, Vic. Hey, folks, my name's Anugrah. I'm a software engineer on the performance and observability team. And for the last 5 years, I've been working on all things metrics. And today, I'm going to talk to you about the evolution of metrics at Medallia. Now, as Vic mentioned, Medallia is a leader in the field of customer experience. And for us to be in this business, it's crucial that we are able to provide a phenomenal experience to our users through the reliability and performance of our own products. This is one of the reasons why Medallia has invested heavily in observability tooling. Now, the evolution of Medallia's metrics platform is really a story of growth from nothing 6 years ago to today, where we ingest over 250 million active time series across 21 environments, including private colos and all flavors of public clouds, evaluating over 25,000 alerting and recording rules, and delivering 1 year's worth of retention. But it wasn't always this way. Let's turn back time 6 years ago. Medallia was in the midst of building out a new cloud fabric, but unfortunately, our monitoring was still relied on legacy tooling and legacy methodologies. Luckily, there was a company right across our office that offered a cloud metrics platform. And it was a simple proposition. You installed their agent, you sent your metrics in whatever protocols, and they did the hard part of operating and scaling the metrics platform. And this is how we got started. And it was critical for Medallia to gain an understanding of the power of time series metrics and gain competency with this new tooling. And Saas platforms are great specifically for this reason. Now, the main problem is that cost typically scales with the amount of data that you send. And as your company grows and you acquire new customers and you build new products, the amount of metrics you generate organically grows. Now, as we approached IPO, we needed to reduce our external costs and facilitate other use cases not supported by cloud providers. It was time to build an internal platform. Now, due to our previous reliance on a cloud vendor, our entire metrics pipeline was push-based. And in 2017, the tick stack was gaining popularity and was already being used in other parts of our organization. On top of that, InfluxDB was a push-based TSDB designed for high throughput writes, which aligned with our use case. So we decided to move forward with the tick stack, but with Grafana as the visualization layer, since it was the industry standard and it had support for multiple data sources. Now, we needed to build out this new platform without compromising the existing setup that our entire organization had become dependent on. So in order to safely experiment, we set up a layer of load balanced Telegraph instances in front of the vendor agent for the purpose of sending the metrics to multiple destinations. And overall, this worked well for a period of time. However, there were several pitfalls. Firstly, it became apparent that with our rate of growth, although we could support the write throughput, we would not be able to support our cardinality requirement, making long-term storage limited. Secondly, due to the lack of federated querying, we had an isolated stack per environment, which wasn't a great experience. And lastly, horizontal sharding needed an expensive enterprise license, which compromised the cost effectiveness of the solution. Luckily, shortly after that in 2018, Improbable.io open sourced Thanos. Now, for those who are unfamiliar with Thanos, it's a set of components that can be added to Prometheus in order to compose a highly available metric system. Specifically, what caught our attention was that Thanos addressed the three concerns we had. First, cost-effective long-term retention with object storage and without compromising on query latency. Second, the ability to horizontally shard Prometheus and circumvent any cardinality bottlenecks. And third, federated querying and hence the possibility of a single pane of glass for all your metrics. Now, in order to adopt Prometheus and Thanos in a seamless manner, we updated the Telegraph forwarders with the Prometheus output plugin, deployed Thanos across our environment in parallel with the existing infrastructure. And in order to give our organization time to adapt to the new ecosystem, the migration to Prometheus and Thanos was a huge success. It addressed all of our scalability concerns, and it enabled Grafana to unify all of our metrics. Though, as Medallia started to expand globally, we began setting up data centers all over the world to support local data laws. Now, with a query fan-out model, your queries are traversing the entire globe, and as a result, your query performance starts getting impacted. And moreover, as you saw in the architecture diagram, Thanos has a lot of moving parts. Setting up and operating the entire stack for each new environment adds a lot of administrative overhead. And with a ton of acquisitions, we suddenly needed to support several public clouds. It became clear that the way we onboarded new environments needed to change. In 2020, inspired by Cortex, Thanos released a new component called Receive, which accepted the Prometheus remote write protocol. So instead of setting up the entire Thanos stack, you could instead just deploy Prometheus to handle metrics collection and remote write the metrics to a central Thanos receive, which brings us to our present day architecture, which has enabled us to support multiple public clouds and has made onboarding new environments trivial. To recap, your metrics platform is just like any software product. As your product needs change and the environment evolves, so must your architecture and tooling. After 6 years and many iterations, we've arrived at a point where we've been able to unify collection, storage, and querying with Prometheus and Thanos. This has enabled Grafana to become the single point of access for all our metrics, regardless of environment, source, or purpose. In the future, we're considering how we can leverage OpenTelemetry to unify instrumentation, correlate metrics and traces via exemplars, and continue unifying our pipeline potentially with Nimir. And now I'm going to hand it over to my colleague, David, who'll talk about how we're expanding our unified access with Grafana to go beyond metrics and include other observability primitives. David?
Thank you, Anugrah. To fully grasp why centralized logging behind Grafana is so important to us, you must first understand the history of logging at Medallia. In the early days of Medallia, we were running applications on bare metal servers or VMs. The simple solution is to write log files to disk. This is fine for a couple of bare metal servers or VMs, but this is very difficult to scale. Things to consider for this scenario are where to store logs, how to implement compression, when and how does file rotation happen, how to implement retention, how to access those log files, who can view them, how to run searches on those log files. The list goes on, but you can see this gets messy very quickly. It was clear that Medallia needed to operate on a fabric. The first fabric Medallia used was Mesos Aurora. This required us to install and run a process on each node that captured Docker logs and shipped those logs to a logging service within the cluster. The logging service within the cluster would save logs to Network File System, or NFS, and ship a subset to a third-party service. Because now we had a fabric, we were also able to create a service to automate compression and retention. While this definitely scales better, it still has some major drawbacks. For example, A simple fix to the logging pipeline required every server to be updated. This meant touching every server and making sure that the changes that we made didn't impact the fabric itself. The risk is high, and because the risk is high, it meant long delays to roll out these fixes. During this time, other teams started to build out their own pipelines for their own specific use cases. For example, the security team built their own pipeline that was for audit logs. The networking team built a syslog service for networking devices. Several teams had needs to capture logs that didn't reside in a container environment. Kubernetes was quickly becoming the standard for Fabric, and Medallia then started to implement that Kubernetes fabric. At this point, there was a great need for a unified team with a stewardship over all things observability. This is when the performance and observability team at Medallia was created. After understanding the benefits of running on Kubernetes, the PoE team was all in on running on the 3 pillars of observability in the Kubernetes environment because of its simplicity. Here are a few examples of what we have done in the recent past for the logging pipeline at Medallia. Run an open source logging pipeline service to capture logs and request the metadata on those logs provided by the Kubernetes API. The same service saves logs to disk and ships a subset of logs to a third-party logging service. Kubernetes also brings annotations, which allows for self-service capability for dev teams to control logging pipeline behavior. For example, writing logs to a disk, or shipping logs to a third-party logging service, or shipping logs to Loki, and even as far as completely turning off logging for an application if there is a need. Kubernetes also allows simplification for managing client-side filtering, and it also continues to run a simple automation for log compression and retention. While things continue to get better using Kubernetes, we still have some problems that we needed to solve, and that is logging costs and running at scale. As we continue to grow at a rapid rate, we needed a fiscally sound way for logs to grow. This includes ingesting logs from all sources, which would include data centers, clusters, new acquisitions, appliances, etc. Another requirement for effective investigations, which include aggregation of information and debug logs. It's something we had been filtering off previously. As Medallia continues to grow, so do the logs. This is the scale we are running at today. Using Prometheus, we are currently reading 1.6 billion log lines per hour, which is an astounding estimated 1.14 trillion log lines per month. And that amount of data, and the amount of data that drives this is about 11 terabytes. This is very large scale already, and we will continue to grow at an aggressive rate. We needed a solution that we could run in-house and continue to scale as we do. Grafana brings much of that to the table here. We are already using Grafana for metrics. LogQL is similar to PromQL, so the learning curve for the dev teams is minimal. A learning for Thanos ruler and Loki ruler using the same syntax, again, removing the learning curve for dev teams. Having the ability for metrics, logs, and traces to be on the same dashboard is the gold standard we're striving for. Loki for the win. I am not giving Loki enough credit here, but it provided a lot of capabilities that we needed and wanted. We are centralizing logs from 18 clusters, and we will be adding several more in the near future. Ingestion performance is working very well with P99 across the globe being below 500 milliseconds. In most cases, query performance looks great. We still have a corner case that we are working on and hope to solve that soon. Dev teams will be able to aggregate their logs, create alerts for their log events, and create metrics from logs. These are all capabilities that Medallia hasn't had across the engineering organization. The next step is to get all logs flowing into Loki, regardless of where those logs originate from. So that required us to defragment the other logging pipelines that had been created earlier. So those next steps include onboarding the security team to ship their audit logs and keeping them safe and confidential using their own tenant. The networking team will be able to use syslog service and ship their logs into Loki so that they can aggregate logs. Work with services that run outside the container environment so we can consume those logs and aggregate on those logs as needed. We're able to do all of this with logging at Medallia because of Grafana and the single pane of glass that Grafana brings for all things observability. Turning it back over to you, Vic.
Thank you, David. For the sake of time, we've left out details of our distributed tracing journey. Perhaps that could be a future presentation that we do at a future GrafanaCon. But in summary, after a lot of hard work, we now have observability under control. One owning team, one pane of glass, one vision. Benefits now include that we have united the three main pillars of observability: metrics, tracing, and logging. Investigations are simplified, so our developers and site reliability engineers can be more efficient. And as an added bonus, we can now deliver insights to engineering leadership that we weren't able to deliver previously. And that is a powerful thing because that can really impact the quality of the decision-making that occurs at high levels in an organization. Also, the heterogeneity and complexity that still does exist, it's really hidden behind the pane of glass. So what had been previously a poor user experience within Medallia for our users of observability is now a much better one. It's much simpler. We have one user interface to observe all the things, and that one user interface, of course, is Grafana. So what's next for us? We really want to spend some time in the next few months or quarters to take a serious look at Mimir and Tempo. So we're heavily invested into Prometheus for metrics. As Anugrah mentioned earlier, we highly leverage Thanos, but we've been moving more and more towards centralization of our metrics, where previously they were decentralized across different data centers in different parts of the world. And Mimir looks like it will potentially be a great solution for that for us. And Tempo as well has benefits. We've been using Jaeger for several years, but the storage, the simplicity of the storage solution for Tempo in particular is really interesting. So we will definitely be looking into those offerings. Custom plugins. This is another area that has us very excited because this allows us to take things that are more bespoke or custom within Medallia in terms of observing our applications and to integrate them into the same single pane of glass. For example, we've had a solution available to our developers for Java applications in Medallia for many years for analyzing Java thread dumps. Once per minute, every Java virtual machine that's running has a thread dump extracted and saved, and it can be queried and looked at. But it's a completely different UI, homegrown. We want to build that into Grafana, so then you can have the temporal correlation of what's going on in metrics or in your traces and see what was going on with thread dumps in that same point in time. Another thing that we want to really consider is, can we take what we've built out for profiling in Java and get that integrated into Grafana as a plugin? Or maybe the community is working on this, right? So these are things that we want to look into and spend time on, and we're really excited about it because it's possible with Grafana. We're not just limited to what comes out of the box. We can build to make things better. And real user monitoring. We're going to be thinking about how do we incorporate that into the unification. And I'm sure we're going to have many other ideas as time goes on. We're never short on ideas. So a few final thoughts or questions. We hope that our story resonates with you and your experiences. Let us know if it does. If you have any questions or you just want to compare and contrast your journey, we really look forward to talking to you. Please feel free to reach out to us at the GrafanaCon channel in the Grafana Labs community Slack workspace. And thank you for attending our presentation. Please enjoy the rest of GrafanaCon.